Section 1.6 is kind of a blended section. It has some stuff from section 1.4, the section where we were given sets and we found intersections, unions, and complements of sets, and some of the stuff from section 1.5 where we drew Venn diagrams. And mostly in this section, we're going to be given Venn diagrams, but they're not going to be blank Venn diagrams. They're actually going to have the elements of sets inside them. And it's going to be important and not terribly hard. If I give you a Venn diagram that is labeled with set names and there are elements inside these sets, it's going to be important to be able to figure out what the sets are. And so let me just give you a Venn diagram that has a universal set and subsets A and B. So this whole rectangle is the universal set U. My goal is to write down all the elements that are in set U, all the elements that are in set A, and all the elements that are in set B, and I'm going to do these in roster form. And for me, it's probably easiest to get the elements of set A and set B, and then I'll work on the universe. So set A, the elements in set A would be anything that's inside the circle that represents set A. So if I look at the inside of that orange circle that I just drew, any number inside that circle is an element of set A, and I see 1, 3, 5, 7, and 9. So I'm going to say set A contains the numbers 1, 3, 5, 7, and 9. So this is a roster listing of all the elements in set A. I'll do the same for set B. I'll figure out all the elements in set B by looking inside the B circle. And so I've kind of colored in a little bit set B in pink, and any element inside this pink circle that I drew, namely 6, 7, 8, 9, and 10, are going to be the elements of set B. And then the universe is any number that's in the entire square. So any number that's inside the square that I see is going to be part of the universal set U. And let me just write those numbers down. So I'm going to go through and look at any number that's in this picture, and I'm going to write them in order. So I see a 1, a 2, a 3, a 4, a 5, 6, 7, 8, 9, and 10. The universal set is going to have the numbers 1 through 10. So for this Venn diagram, the three sets that are implied by the Venn diagram are the universal set, the set A, and the set B, and these would be the elements of those sets. So the first few problems in this section just ask us to do exactly that, and some of them are kind of a nuisance. So let me flash up your problem 1, which is I would classify as kind of a nuisance because it has 20 elements in it. But what you need to do for problem 1 is pause the video and write down all the elements in the universal set, all the elements in set S, and all the elements in set E. Quite honestly, I don't feel like doing your problem 1. I was going to do it with you. I'm staring at my problem 2, and it's so much friendlier. I'm going to do problem 2. So here's my problem 2. I don't do well at drawing Venn diagrams that have elements in them. So most of these I just search Google Images to figure out to get pictures. And this is an odd Venn diagram that I stole from Google. Here's a Venn diagram that represents the sets A, B, and E. The universal set is called E in this problem. It's unusual because usually we always call the universal set U, but you can call it whatever you care to. I mentioned earlier in the last video that you can call it the squiggly Greek letter Z. But let me try to do this problem real quickly. First, I'm going to list the elements in set A because that's easy for me. The elements in set A are any of the elements inside the A circle. So set A is going to have the numbers 1, 2, 3, 5, 6, and 9. I like to write them in order, but I don't have to, as long as I get all the numbers that are inside the circle that represents set A. That would be a fine representation for set A. Now I'll do set B by looking inside the B circle, and any number inside the circle that I just circled is going to be part of B, which is going to be 2, 3, 4, 5, 7, 8, and 10. So for set B, I'm going to say it has the elements 2, 3, 4, 5, 7, 8, and 10. And then the universe, which is set E, is going to have any number that's drawn anywhere in this picture. So any number that's inside the rectangle has to be listed when I list the elements of set E. And I like going from smallest to largest. I think I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So in for set E, I'm going to write the numbers 1 through 12. The bigger the sets are, the more of a nuisance this is to do. You'll notice that I have my set braces, and I just had them, I typed them in just to save myself a little bit of work. Here's your problem 3, and I'll tell you what, I'll do 3 with you because I don't know how readable this is. So first I need to list the elements in set, well, I can do any order. I like doing A first. Just do these alphabetically. So A has only 3 elements in it because in the circle that contains A, there's just the letters A, B, and C. In set B, this is where it gets not so readable. Set B has any letters in the circle that I just drew around B. That's going to be C, D, E, and F. So that C is in both sets. It's part of the intersection of those two sets. That E is probably hard to read. And then the universe, the universal set is called the Z, the Greek letter. At least I think it's a Greek letter. That's the name of the universal set. No, I just wrote U here for universal set. And when I label the universal set, I don't include the name of the set A nor the name of the set B. I include any letter that's anywhere inside this rectangle when I label the name of the universal set. And I try to go in order, so I see A, B, C, D, E, F, G, H, I, J. So I'm just going to do all the letters up to J. J, A, B, C, D, E, F, G, H, I, J. Would be good enough for the answer to problem 3. I'm not going to do problem 4. I don't think these are that particularly hard to do. Problems 5 and 6 have 3 sets inside of a universal set. And your problem 5, the universal set is called this Z. If you call it U, I don't hardly care. Set A is in the upper left, set B is in the upper right, set C is in the bottom corner. You need to go through and list all the elements in set A, set B, set C, and then all the elements inside the universal set. So pause the video and give that a go, and I'll move on and do my problem 6, which is easier because I guess you have the numbers 1 through 19. Well, you don't even have 1 through 9. Heck, let's just do 5 together, and I'll skip 6. So let me do set A first. So set A is going to have any number inside the A circle, and I see 4, 6, 8, 10, 12, 14, 16, and 18. So the even number starting at 4. So I'm going to get 4, 6, 8, 10, 12, 14, 16, and 18 to represent my set A. For the set B, I see 6, 9, 12, 15, and 18. So I'm going to write 6, 9, 12, 15, and 18. A has even numbers between 4 and 18. B has multiples of 3 between 4 and 18. Set C, if I look inside the C circle, inside the C circle there's 5, 6, 10, and 15, and I don't really know how to describe set C. Those are the easy sets for me. The union's kind of not fun. I look for the smallest number. I see 4 is the smallest number. And then hopefully it has every number up to 19. So 4, I see a 5, a 6, 7, 8, 9, 10, 11, 12, 13, 14, I'm going to write over my set brace here, 15, 16, 17, 18, this is horrible, and 19. Those would be all the elements in the universal set called Z. I think I got every single element. These, in some sense, was nice because there weren't any numbers skipped. Well, 1, 2, and 3 were skipped, but there wasn't like, maybe 13 wasn't skipped. So I feel good about that. Not going to do 6. You can give 7 a go. Doesn't look so hard. And so we have the universal set U, the set A, the set B, and the set C. Hopefully it's nice and readable. Pause the video and give it a go because I'm going to flip it and do problem 8. So for problem 8, I'm going to start off doing set A. A has 2, 4, 6, 8, 12, and 20. So 2, 4, 6, 8, 12, and 20. B has 3, 6, 9, 12, and 15. C, inside the circle that I'm drawing right now in a different kind of blue, has 5, 10, 15, and 20. And for set U, it's anything that's inside the universe, and I need to go in order. So I'm going to go 2, 3, 4, 5, 6, and there's not a 7. So let me get started with my universal set. 2, 3, 4, 5, and 6. Let me just mark these out. I did 2, 3, 4, 5, 6. The next smallest number I see is 8, 9, then 10. So let me do 8, 9, and 10. 8, 9, 10. And all I'm left with now is 12, 15, and 20. So the universal set has 2, 3, 4, 5, 6, 8, 9, 10, 12, 15, and 20. This is almost overkill to do 8 of these problems, but let's, deal with it and move on to the next thing that we need to do. The next thing we need to be able to do is use Venn diagrams that contain elements to find answers to complement, union, and intersection questions. So how am I going to find the set A complement intersection B for the sets A and B and U that's described below? Not particularly hard to do this. So to do this, I need to make a picture and find the region that A complement intersection B represents. So I'm going to do that by making a picture like I did in the last section. And of course, when I do intersection, I have to use multiple colors. The first thing I'm going to represent is A complement. And A complement is anything that's outside the A circle. So A complement could be that picture right there. I'm attempting to draw A complement intersection B. And of course, when I do intersections, I need to pull out a second color. Now I'm going to shade B in a new color. A complement intersection B is any represented by any of the regions where I have both colored shadings. So I have the A complement shaded, I have the B shaded, and the only region where I had both colored shadings seems to be right here. So this is a picture of A complement intersection B. I'm going to transfer that picture to the actual diagram that was given to me, and the answer to what A complement intersection B is for the sets A and B given in this diagram is going to be any element that's in the shaded region. And the elements inside the shaded region, they get pretty tough to read. Let me see if I can zoom. Well, I can't zoom in when let me just raise this a little bit closer. So the elements inside the set that I shaded are 6, 8, and 10. The answer to what A complement intersection B is for this Venn diagram, I can write the problem. I could say A complement intersection B equals the set that contains the numbers 6, 8, and 10. Or, if I want to, I don't need to write the problem with the answer. I could just say 6, 8, and 10. That's essentially what every problem in this section is going to ask us to do. It's going to give us a Venn diagram that has some elements inside the sets, and we're going to be asked to find a set by first doing a shading to find the region represented by the set, and then looking into the diagram with that shading kind of added to the diagram to figure out the contents of the sets. This can be messy to do because sometimes the sets are hard to find. And that's going to be the case for this next example. So let me try to, on my clean sheet of paper, help us find this A union B complement intersection C for this diagram. And of course, I'm going to spend a lot of time doing the shading and a little time doing the answer once I get the shading done. So first, if I'm trying to find the region that's represented by A union B complement intersection C, the first thing I'm going to need to do is the inside of the parentheses and sketch a graph of A union B. So I'm going to draw a Venn diagram that looks something like the Venn diagram that's given to me. Other than I'm not going to take the time to put the numbers in. I don't need to do that. That's not so important. So there's my set A, my set B, and my set C. To do A union B, because unions I only need one color, I'm going to color in the whole A circle, and I'm going to color in the whole B circle. That's a picture of A union B, not a picture of A union B complement. So the second thing I'm going to do is figure out what A union B complement is. And A union B complement is pretty easy to draw because it's going to be anything that isn't shaded when I graphed A union B. So again, this is a reasonable representation of the diagram that's given. And to draw A union B complement, I need to take the graph that I just created and find the complement of it, which means anything that was white needs to become dark, and anything that was dark needs to be left white. So this is a picture of A union B complement. On this same graph, I'm going to intersect C. So now I'm going to introduce a new color. So I was asked to find A union B complement, which I found first. And then after I find that, I need to intersect it with C. And when I do intersecting, I pull out a new color. So I'm going to draw C in a new color. And to draw C, I just take the entire C circle and draw the inside of it. So now I'm ready to say what the A union B complement intersection C actually looks like. This is going to be my fourth and final step, and this is a drawing, the shading that I'm going to transfer to the actual problem. So because I was asked to do an intersection, I look for where my shadings overlap, and my shadings overlap only in this region down here. So this is a picture of what I needed to come up with, because to do this problem, I have to find the elements that are in the set A union B complement intersection C. I'm going to transfer this onto the picture that's given to me, and the answer to this problem is just going to be the elements 5 and 10, or the set that contains the elements 5 and 10. So when I go to write my answer to this, I would likely be lazy and just say it's the set that contains the numbers 5 and 10. If you don't want to be as lazy as I was, you can say the set A union B complement intersection C equals the set that contains the numbers 5 and 10. That's kind of all there is to do in this section. It's just drawing pictures and applying those pictures to the work. So let's just jump in and do some homework. So I'll let you do 9 and I will do 10. And to do 10, from this picture that's given that has a set A and a set B, I just need to draw B complement. B complement's easy for me to draw. B complement is anything that's outside the B circle. So this is a very fast drawing of B complement, and that's only one set. I don't need to take a lot of time trying to figure out what that is. I'm going to transfer that to this diagram, kind of the best I can anyways. I don't need the shade super great if I don't care to. The set that I'm trying to find is going to be anything that's labeled or shaded in those pictures. Of course, not the set names A and B. So let me try to just go through this and write my answer to number 10. And I'm going to try to go alphabetically. Anything that's shaded gets in my answer. So the A and the B get in my answer. The C shouldn't be shaded, so that's not going to be part of my answer. The D, E, and F aren't shaded. That's part of my answer. G is. H is. I is. And J is. Pretty sure that's everything that I have written here. Really? So for your problem 9, just in case you're hoping to find an answer, that's what I wrote for problem 9. Hopefully that matches up with your answer. Some of these problems we've already done. So if you have your homework for section 1.4 handy and you looked at your answer to number 3, you could use your answer to number 3 to save some time on doing the shading. I won't save any time on doing my shading. Let me do number 12. I'm going to figure out what A union B complement is. And I could do that in one shading. Unions are super easy for me to do. I prefer doing unions when I'm doing shading. So how do I shade A union B complement? Super easy. I shade the entire inside of the A circle, and that's my picture of A. Unions, I only need one color. B complement is anything outside the B circle, so now I'm going to shade B complement, which is shading everything outside the B circle. Some of the stuff I already have shaded. And that's a picture of A union B complement. Unions are my favorites to do. Let me transfer that to this picture. You don't physically have to transfer it if you don't want to. You can actually just visually understand what would be shaded, but I kind of is dead. That's a picture of A union B complement. Write down the elements that were shaded to get my answer. And for number 12, the only thing that's not included is a C, D, and F here. Let me try to go alphabetically. I see an A, a B, a C, so I'm going to include an A, a B, a C. I'm not going to include D, E, and F. I am going to include G, H, I, and J. So if you were able to do the shading that we had in the last section, then you should be completely good with this. Let me help you through problem 13 and not do problem 14. I actually think your problem 13 is a little bit easier. So for problem 13, I need to find the region represented by A intersection B complement. So I'm going to start off by drawing A intersection B. And usually I need to do that with two colors. I think it's not that hard to understand what A intersection B is. So, heck, I'll do it in two colors. So for A, I circle in the shade in the A circle. For B, I shade in the B circle. A intersection B is any region where the shadings overlap. So the A intersection B, for your problem 13, would be just the region where I have both colors, which is the region where the circles overlap. And quite honestly, I generally wouldn't, I would just say A intersection B is that little area where the A and the B circle overlap, as opposed to taking the time to do it in two pictures. Not done. The graph I need to have is A intersection B complement. So I'm going to take the complement of this picture. And how do I do a complement of a graph? I shade everything that's not shaded and make white anything that is shaded. So the little region in the center is going to stay white, and everything else is going to become shaded. So this is not maybe the best picture of A intersection B complement, but it's absolutely good enough. I'm going to transfer that to the diagram that's given to me. So I'm only going to keep this center spot open. And you don't really have to shade these, just as long as you understand the elements that you need. If you don't take the time to apply the shading to the picture that you need, as long as you can get the sets, I don't care if you shade as much as I shade, but there are the elements that I need to pick out. I need to pick everything but the letter C, because the letter C is the part that isn't shaded in the graph of A intersection B complement. So my answer, I'm just going to go in order here. A, B is going to be in my answer. C isn't. D, E, and F are going to be in my answer. And then G, H, I, and J. So I have my answer for 13 handy. So 13, I wrote A, B, D, E, F, G, H, I, and J, and I think that's exactly what that is. So I feel good about that answer. Yuck. So we're just in the 2-set world. Eventually we'll get to the 3-set world. I'm going to do 16, you can do 15. So to do 16, I need to start off by doing the inside of the parentheses first. And because it's a union, I can do it in one color. So to do A union B complement, I'm going to shade the entire A circle. There's the A part of this. And then the B complement is anything outside the B circle. So this is a picture of A union B complement. That's not the picture that I need to use to figure out what elements are in my answer. I need to find the complement of this, and that's easy for me to do, and it's actually not going to have that much shading. The complement of a set, again, is anything that's shaded becomes white, anything that's white becomes shaded. There's only one white region. Now I'm going to shade that region. That's a picture of A union B complement, all complement. I'm going to transfer that shading onto the graph, the Venn diagram that's given. And the answer to the problem that I need to work with is going to be what's ever been shaded there. And that looks like that's E, D, and F. So for problem 16, the answer is going to have the elements. The set's going to contain the elements E, D, and F. If I had to guess, your problem 15 is going to have the letters A and B in it, and there's the answer to 15. If you got A and B, you did well. So we have 18, 19, and 20. I feel like I'm going to skip 18 and do 20 just because the videos get so long, and I think I'm just going to skip it. Let me do 20 for you, and you can... Oh, Wow, 19 and 20 look pretty similar, so I guess I'm doing 19 as opposed to 20 because of the same problem. So let's figure out what A complement intersection B complement looks like pictorially. The smaller I make these graphs, the less shading I have to do, and complements need a lot of shading. So I need to use two colors because I have intersection. So the first thing I'm going to draw is A complement, drawing it in this peachy color. A complement is everything that's outside the A circle. So that's a picture of A complement. And now I'm going to draw B complement by doing everything outside the B circle. So I'm going around that B circle, and I'm shading absolutely everything outside the B circle. And now I have to try to figure out where do I have both colors of shading, because where I have both colors of shading is going to be where I need to focus on for my answer. And it looks to me like inside that circle there's only pink, there's no shading there. In that part of the circle there's only orange. Outside the circles I have both colors of shading. It looks to me like the region that has both colored shadings is that part of the region there. So I'm going to transfer that to the drawing that's given to me so I could figure out the answer to problem 19, which is going to be the same as the answer to problem 20, and the only number that I covered up is 8. So the answer to problem 19, as well as the answer to problem 20, is the number 8. And it's right there. All right, you can give 21 a go. I'll give 22 a go. So for 22, I'm going to start off by drawing A intersection B. And again, I can do A intersection B real quickly without taking the time to do a monstrous amount of shading. A intersection B is just the region where the A and the B circle overlap. That's what A intersection B is going to look like in one clean coloring. It's where the A and the B circles overlap. Unfortunately, I need the complement of that. The complement of that is going to have the region that I have darkened white and everything else colored. So the set that I'm trying to figure out has one little white sliver in it. So there's a picture of A intersection B complement. I'm going to transfer that to the drawing that I have here, the best I can anyways. And doesn't have to be that great. In fact, you don't really even need to transfer it if you can visualize what you're trying to attack or trying to get. So my answer is going to be every number but the number 4 that's represented in this diagram for 22. So 1, 2, 3, not 4, 5, 6, 7, 8, 9, and 10. When you do problem 21, you're trying to get 5, 6, 7, and 9, assuming my answer is correct. All right. All right. So apparently, if you had my work for 1.4 number 6, that would be the shading you need for 23. I'm just not pulling any of the shading back. Let me do 24 real quickly. So for 24, I need to start off and shade A complement union B. It's a union, so I could do it in one color. So I make my Venn diagram. If I don't even write the names of the sets, I don't care. A complement union B. A complement is everything that's outside the A circle. So this is going to be a picture of A complement. As long as I don't shade anything inside the A circle, I've got a picture of A complement. A complement is shown, and now I'm going to union it with B. Unions, I only need one color. I'm going to color in the entire B circle. And that's a picture of A complement union B, but that's not what I need. I need the complement of what I've just drawn there, and that's a super easy complement to draw because anything that's white becomes colored, anything that's colored becomes white, and so that little region right there is going to be the only region that winds up being colored. I'm going to transfer that to my diagram that's given to me. And when I go to answer problem 24, I'm going to write down the elements that I just covered up. The answer to problem 24, I just need to write the set that has the numbers 1, 2, 3, and 10. Just because I have them handy, 23 that you're supposed to do is supposed to have 4, 5, 6, 7, 8, and 9. Somehow I don't see a problem 25. So you can just skip problem 25. My work here says there's a problem 25, but as I get here I don't see a problem 25 and I just see 26. So let me do 26. This is a monster problem. And the first thing I need to do, I need to work from left to right. I need to draw a picture on a 3-set Venn diagram of A intersection B. And again, I can do real simple intersections without doing a lot of horrible work. So I'm going to do this A intersection B quickly. A intersection B is just where the A circle and the B circle overlap. So there's a picture of A intersection B. Done quickly. I think that's not too big of a stretch to be able to figure out A intersection B is where the A and the B circles overlap. And now I'm going to union that with C complement. And to union it with C complement, because I'm doing a union, I don't need to add another color. I'm going to just do C complement, and C complement is everything outside the C circle. Same color because I'm doing a union. Staying outside the C circle, but getting right up to the C circle the best I can. So now I've taken A intersection B, I've unioned it with C complement, so I get a kind of an odd looking graph. And in my graph, I need to have this region and everything outside of the C circle highlighted. So this is going to be a picture of what I need to focus on. Basically, I don't get the 1, I don't get the 6, I don't get the 7 and the 10, and all the rest of the numbers in the diagram I get, and I like to just go in order, so I see 2, 3, 4, and 5 highlighted. The 6 and the 7 aren't, but the 8 and the 9 are. The 10 isn't, and I think I've gotten everything. 2, 3, 4, 5, not 6, 8, and 9. I think that's everything. Apparently, the graph for problem 27 that we need is done in the last video. Let me just do this with you real quickly. So let me just do 27. I think 27 is actually easier than 28. So for 27, I'm going to start off figuring out what A intersection B complement is. I could do this just by writing it down, but I will do it in multicolors just to be safe. There's my set A, my set B, my set C. To do A intersection B complement, I'm going to draw set A in a color. And then I'm going to do B complement in another color. B complement is anything outside the B circle. So I go right up to the B circle, all around it. So I can now figure out what A intersection B complement is. That's any place where I have both shadings, and I like to bring this down into another picture. So I'm going to transfer the picture that I just drew, but clean it up to only show the area where I have intersection. in intersections where you have both colors, and it looks to me like I have both colors in this region right here and that region right there. So there's my picture of A intersection B complement. Finally, I need to, after I found A intersection B complement, union that with C. Because now I'm doing a union, I don't need to pull in a new color. I can continue with this pink color, and now I'm going to do the union C by shading in C. There's a picture of A intersection B complement unioned with C. Transfer that to my diagram. I get this region here, these three regions here, and this region down here. So this is crudely shaded, but good enough. I have shading in the regions that need shading, and let me write down the answer to problem 27 now. The smallest number I see is 1, then I see 3, I don't have 2, I don't have 4, then I see 5, 6, 7, and 10. I believe the answer to 27 is 1, 3, 5, 6, 7, and 10. And I look at my answer 27, 1, 3, 5, 6, 7, and 10. I feel good about that. I'll let you do 29 because it's got all those ugly intersections. I'll do 30 because it has unions. In unions, I can do all in one color. So to do 30, to do A union B union C complement, it's going to wind up having a lot of shading, but it's not particularly hard because for unions I could do one color. So first thing I'm going to do is A, shade in the entire A circle. Then I'm going to do B, shade in the entire B circle. Then I'm going to do C complement, shade everything outside the C circle, even some of the stuff that I already have shaded. So that's actually a picture of A union B union C complement. Now I just need to transfer that visually or physically into my picture. And the only region that isn't shaded has the numbers 7 and 10. So when I go to write my answer, I'm going to include all the numbers between 1 and 10 except not 7 and not 10. So I'm going to go 1, 2, 3, 4, 5, 6, skip the 7, include the 8 and the 9, skip the 10. Just in case you're checking your 29, I just have the number 4 for problem 29. Let me skip 32 and we can work 33 together. They're similar and might as well just help you just in case you're getting stuck. Again, if you could do 33 without me watching, that's way, way better than you needing to watch me. So pause the video and give it a go. And the answer for 33 apparently is 2, 3, 4, 5, 8, 9, 10, 15, 20. Let's try to get you there. Let me do 33. First I'm going to do A intersection B, the inside of the parentheses. And again, I can figure out A intersection B quickly because it's just where the A and the B circles overlap. So A intersection B is that. Unfortunately, I need A intersection B complement. To do A intersection B complement, I take the complement of that picture, and of course the complement of any diagram is going to have everything that was white become shaded and everything that was shaded become white. So now I'm going to shade everything in the above graph that was white, and I'm going to leave that little area between the circles A and B white. And so that region is the only region that's white. Everything else is shaded. So that's the A intersection B all complemented part. And now I need to union that with C. Pretty easy to union it with C because I'm doing a union. I don't need another color. I just need to go now and fill in the entire C circle. So the only piece that's white is that piece right there, and everything else becomes shaded. So if I transfer that to the diagram, and you don't have to transfer this to the diagram, as long as you can figure out the elements or in the regions that you need to focus on, that's fine. So when I go to do problem 33's answer, let me see what it is. I see 2, 3, 4. I don't see 6. Oh, I skipped the 5 here. 2, 3, 4, 5. I don't see 6, but I do see 8, 9, and 10. I don't like this set because the numbers aren't in order. It makes it so much harder for me. So let me start marking these off. I marked off 2, 3, 4, 5. I'm skipping 6, 8, 9, 10. I'm skipping 12, and then 15 and 20. So I'm probably going to need to destroy that diagram a little bit in order to answer the question. Let me double check. On my problem 33, I have 2, 3, 4, 5, 8, 9, 10, 15, and 20, so I feel perfect. So you have 3 more problems to go. Let me do 36, and you can do 35. So for 36, I need to do the parentheses first, which is A union C. Easy for me to do a union because I only need one color. So I'm going to take my graph of A, B, and C and show A union C. A union C I get by first shading in the entire A circle. And then union, so I use the same color, and I'm going to draw in the entire C circle. So that's a picture of my A union C for problem 36. Now I need to intersect that with B. I need to pull out a new color, and now I'm going to shade the entire B circle in that new color. And the regions where I have both shadings, it looks like this region right here, this region right there, and that region right there are the regions I have both shadings. Those are the regions that are going to be in the final shading for B intersection A union C. So I'm going to transfer this to my drawing. So that is B intersected with A union C. I'm going to transfer that to my drawing. And my answer for problem 36 is going to be 6, 12, and 15. When you do 35, your answer looks like a bunch of evens. 2, 4, 6, 8, 12, 15, and 20 is what I wrote down. Hopefully that's correct. I don't know how much my answer looks like that answer, but my goal was to leave kind of those 3 little segments of the graph unshaded, and I shaded the graph that I intended to shade, which is those regions. So as you're going through and doing your shadings, I mean, I have to cut you a little slack because I don't have the best shadings ever for some of my problems. All right, so I'm going to do 12, and you can do 13. I don't want to do all your problems. Lots of intersections here, so I need multiple colors. So as I do number 12, I'm going to work from left to right. I'm going to start off doing A intersection B complement. And again, I can do this in one shading if I'm not trying to explain how to do it. If you can do this in one shading as well, that's better than having to take the 2 shadings to do the intersections. So A intersection B complement, let me do my A in orange. That's everything inside the A circle. And I'm going to do my B complement in pink. That's everything. If I make a band around the B circle, that's everything outside the B circle. So that's technically the entire A circle drawn in pink, the entire the outside of the B circle, the entire A circle drawn in orange, outside of the B circle drawn in pink, and this region, I need to refine that into a second graph that shows just the part that I need to show. So the region where both the shadings overlap is not so clear. So I need to be outside the B circle and inside the A circle. That's what this means. It means inside the A circle and outside the B circle. The region of the graph that's outside the B circle and inside the A circle is going to be this region right here. This region that's outside the B circle, it's inside the A circle. In this region, outside the B circle, inside the A circle. The rest of the regions are either not inside the A circle or not outside the B circle. So the two shadings that I did, they overlapped in that region. Now, to this graph right here, I'm going to add the last part. The last thing I need to do is intersect that graph with C. And how do I intersect a graph? I bring out a new color to represent the set. So I just drew C in orange. My answer is going to be where I have both color shadings. So intersections, it usually takes me a couple of graphs to represent. My answer to the region that needs to be shaded to represent A intersection B complement intersection C is going to be the regions in this graph where I have both the blue and the orange shading. So that's just blue. That looks like blue and orange. And this little circle right there, that's unshaded, unshaded, unshaded. Just orange, blue and orange, just blue, no shading. So the region that I'm going to need to show is just this region right here. This is the only region that has both blue and orange shading. Because just blue, just orange, no shading, no shading, no shading, no shading. My answer for problem 12 should look just like that. Your answer for 13 should look something like that, just in case you gave 13 a go and you wanted to check. Let me try to get 15 with you. Let me try to get this answer for 15, and I won't do 14. So again, if you're not feeling good about these, pause the video, try to get 15 accomplished, and if you got it, fast forward through this and don't watch me do it. So the beautiful thing about problem 15 is that there's no intersections. And when there's no intersections, I don't have to worry about multiple colors. So on one graph simultaneously, I'm going to draw each in one color. I'll use blue. First, I'm going to draw A complement. To do A complement, it's the entire region outside the A circle. Let me try to draw this in by my standards nice. So A complement is everything, absolutely everything that's outside the A circle. So I've got that done. And now I'm going to union that with B's. In unions, I don't need to pull out a new color. To unioning it with B, I'm going to shade everything inside the B circle. Some of it was already shaded. I just darkened it up, but it didn't matter whether I did or didn't darken it. And then lastly, I'm going to, because it's another union, keep my blue color and do the C. And now I'm shading everything inside the C circle. Anything that's been shaded, regardless if it's been shaded once, twice, or 3 times, is going to be part of my answer to problem 15. The only region that's empty is this little part of set A, and that's exactly the answer that I have drawn on your answer key. All right, so I'm going to do 16 and let you do 17. I'll flash up the answer to 17 so you can check your answer. And again, if you don't need to watch me do 16, fast forward through it. It doesn't hurt my feelings at all. The first thing I'm going to do when I do problem 16 is do to B intersection C. And quite honestly, I can do that in one graph, and I'm going to start being lazy. Should I? Yeah, I think I'm going to start being lazy because it shouldn't be that hard to figure out an intersection of 2 sets. So B intersection C is the region where the B and the C circles overlap. I could draw the whole B circle in one color, the whole C circle in one color, and figure out where the shadings overlap. Those shadings are going to overlap right there because those are the regions where the B and the C circle overlap. That's what B intersection C is. Unfortunately, I don't need B intersection C. I need the complement of B intersection C. So now I'm going to draw the complement of B intersection C, and that is going to cover up almost everything because the only thing that's going to be left white is the area that's blue. So B intersection C complement is everything outside that, everything that I haven't shaded above is going to become shaded to do B intersection C complement. I got my new markers, but I don't like them. They're harder to draw with than the markers that I've used forever. So that's a picture of B intersection C complement. All I need to do now is union that with set A to get my answer. And because it's a union, I should be able to get my answer all in one graph and all with one color. So I'm going to union this graph with set A. And to union it with set A, I circle and I draw in everything in set A. The only region that's empty is this little region right inside the overlapping part of the B and the C circle. So I don't know if that's the best drawing in the entire world. Hopefully, you can figure out from my work from my drawing what the answer is. Just has a little region right there open. And again, just in case, your answer to 17 looks like that. Let me walk through 19 with you and see if we can get this really odd looking region for our shading. It's actually going to be an easy problem. So in 19, I won't do 18, I'll do number 19 for you. In 19, because there's a parentheses, I have to do it first. So the inside of the parentheses in number 19 wants me to do B intersection C. And again, that's just where the B and the C circles overlap. I can do that using multiple shadings, but hopefully I've done enough intersections that you can start to realize what intersections look like. So B intersection C is where the C circle and the B circle overlap. That's those two regions right there. That's that's where the B circle and the C circle have in common. Now I need to finish this up, so I did the parentheses first. To finish this up, I'm going to union A with this. I don't need to pull out another color to do union A. I just need to now, with my same color, draw in the entire A circle, and that's going to be my answer because that's how you union sets, by just adding the new set in the same color. When I look at my answer to problem 19 compared to the answer that I've just written, they're supposed to be the same. So you should, again, be able to tell the regions that I have highlighted, the best you can. So just a few more problems. Our problems for problems 20 and 21 are so similar. I'm going to do problem 20. I'm going to start off by doing the parentheses. The parentheses is a union, so I can do it in one color. I need to do A union C. I'm going to represent that in one color. So I have my universal set, my set A, my set B, my set C, and A union C. In one color, I'm going to shade the entire A circle. And in that same color, because it's a union, I'm going to do the entire C circle. So that's a representation of the A union C. To this, I have to intersect B. So now I have to do B intersection, that set A union C. A union C I have represented in blue. Because I'm doing an intersection, I need to pull out a separate color. So I'm going to do, on the graph of A union C, I'm going to graph B, which is anything inside the B circle. The answer is going to be any region where I have both colored shadings. And my answer to problem 20, I need to interpret the graph that I have just drawn and any of the regions that have both the blue and the pink shading simultaneously, I'm going to bring out and write in my answer. So it looks to me like this region up here has both colored shadings, the region under it has both colored shadings, and the region to the right of it has both colored shadings. Any other of the regions either have no shading, or they're shaded just in pink or just in blue. So this is what I would call the answer to problem 20. Your 21 should work remarkably similarly. We're left with just one problem to do. And let me do your 23 again. So you can pause the video, try to do 23. And if you can't get it, watch me do it. If you can't, you're shooting for that answer. So if you do 23 and get that answer, you don't need to watch me do it. You're done watching the video. If you can't do 23, let me help you through it. So for 23, I have to do the inside of the parentheses first, which is B union C. I can easily do that with one color, because unions I do in one color. So I draw my union, my A circle, my B circle, my C. B union C, one color I draw in the entire B circle and the entire C circle. That's B union C. I have both the B and the C circle represented perfectly. Now I'm going to complement that, and of course to complement a set, you shade what's not shaded. So I'm going to take the set that I've just drawn and form its complement. I form its complement by shading what's not shaded. So what's not shaded, or what's in white in the picture that I have just drawn previously, is now going to become shaded. So this is a reasonable picture. That I would call B union C complement that. I'm not done, because in problem 23 I have to intersect that with A. So now I need to do A intersection B union C complement. To do an intersection, I pull out a new color. So my B union C complement is represented in blue. I'm going to represent my A in pink. And to represent A, you shade the entire A inside of the A circle. And of course, intersections, I need multiple graphs. The next graph is going to be my answer. And my next graph is only going to have the region in the above graph where I have both the pink and the blue shading. And that looks like just this region right there. That small part of the A circle is the only region where I have two colors. So if you're careful with these and just kind of do the right orders of operations, it's not horrible to do. There's just the three operations, and now it's just drawing pictures to represent the three operations. And again, if I look at my answer to problem 23 and I look at this, they're intended to be the same picture. All right, so the next section is doing more Venn diagrams, so you need to be real comfortable with the Venn diagrams before you move on to the next section.